Okay, so this is a cantilever section, and we want to work out what the shear force or bending moment might be at any point. So let's pick this point here, for example, okay? And I'm going to call this distance x, and we're going to call this height here, let's call it y, okay? So I would say that the slope of this line, let's let this point here be 0. The slope of this line is the change in y. Well, y goes from 0 here to w naught. So it's w naught minus 0 all over the change in x. Well, x here is L minus naught, which is equal to w naught over L. So that's the slope of that line. So if I want to get the value of y here, I would say y is equal to mx, which is equal to w naught over L x. So the load at any point is equal to w naught over L x. And we can say then that is the value. If I want to get the force then, well, I need to work out what's the area here. What's that area? So it will be, it's the same over any triangle, so that the shear force V will be, well, for any triangle, let's say it's yx over 2, okay? So in our case, it'll be w naught over L x times x over 2, which is equal to w naught x squared all over 2L. So that's the shear force at any point along this beam. If I want to get the bending moment, well, the bending moment would be the force multiplied by the distance. So if we take this point here, that's force is going to act through the centroid, okay? And that centroid there, that distance there, is 1/3 of x. So if this now becomes x, this distance is 1/3. Okay, so it's acting there. So the bending moment will be the shear force, which is w naught x squared all over 2L multiplied by the arm, which in this case is going to be x over 3. So it's 1/3 of that x. And that is equal to w naught x cubed all over 6L. So that's the bending moment. That's the bending moment at any point along this beam. Okay, and when x is at its max, so when x is equal to L, and that's equal to w naught L squared over 6. That is the maximum bending moment. Okay, so that's what it is for uniform distributed load. If I was to plot that, that's the shape I would get. So there's the bending moment here in orange, and this is the shear force in blue. What I should have said, I should have put a minus before all of those because the forces were acting down. Yeah, but you'd probably work that out yourselves. Okay, so that's the shear force and bending moment of a uniform varying load on a cantilever section.